Welcome back. Problem 5.104. This problem is taken from chapter number 5, Analysis and Design of Beam for Bending, and the book name is Mechanics of Material by Beer and Johnston, 6th edition. And the topic is still singularity function, or it is also known as Macaulay's method. So statement is using singularity function, write the equation for shear and bending moment for the beam ABC under the loading shown. And in part B, use the equation obtained for moment to determine the bending moment just to the right point of point B. So you can see this is the beam, clear, and having a point load at point A, which is P, and you have been asked to find the shear and bending moment equation for the beam. So let's start with the solution. So if you remove this fixed support at point C, so you will be having a reaction force CY, you will be having a horizontal reaction force CX, and you will be having a moment about point C which is equal to MC. So again, using a force couple system, if you move this point P load to the point B, so what you will do is that you can transfer it to this point, but you can see there is a perpendicular distance which is A, and it is producing moment which will be equal to MA in counterclockwise direction. So what you will do is that you will replace this with a moment that is equal to M multiplied by A. So we will draw the free body diagram for the beam which is shown in the diagram. So this is the beam, and this is point B where you have a load of P by using force couple system, and you will having a moment in counterclockwise direction which is equal to P into A, and distance from this point which is point A till point B, this is point B, this is point A, is A, and distance from B to C is also A. And we have shown that there is a vertical reaction force CY as well as CX as well as moment MC. We are not interested to find out this MC, CX and CY because they will be not used, and the last term starting from this left hand side to the right hand side, this term on the right hand sides will be neglected, and you know that I have solved too many problems on that. Now what we will do is that you can see this is the figures for loading, this is for shear force, and this is bending moment. So starting from the left side from A to B, you can see there is no load, and at point B you have a load which is P that is acting downward. So you can see you will use this equation, this figure, that is minus P acting at a distance of A. So shear force equation will be this one. So I will write V of X is equal to minus P into X minus A power 0. And we have a moment as well as at this point which is PA, and you can see for moment acting at point A from the start, the shear force is 0. So there will be no term for the moment. So we will only get shear force equation will be equal to minus P into X minus A power 0. This is your equation number 1. Now moving for bending moment equation. Bending moment equation. I will write M of X. So again for a load of P, you can see this is P that is acting downward. So the bending moment equation is this one. So I will write minus P into X minus A power 1 because this P is acting at a distance of A from point A. And we have a moment as well which is PA. So due to the moment equation will be this one. So I will write minus this M naught will replace with PA. So PA into X minus A power 0. And we can say that this will be our equation number 2. So equation 1, and I will write equation 1 and equation 2 are required shear force and bending moment equations using singularity function. Now this is the answer of our first part. Now in second part, in B part, it is given that use the equation obtained for M to determine the bending just to the right point of point B. So this is point B. So just right to the point B. Here we will take x is equal to A and we will put it in equation number 2 in order to find the bending moment just to the right of the B. So put x is equal to A in equation number 2. So moment about that will be equal to moment about point B, that will be minus P into A minus A power 1, clear, and minus P into A minus A power 0. So it will be equal to minus P into A minus A is 0, 0 power 1 minus PA into 0 power 0. So you can say 0 power 1 is 0. So it will be minus P into 0 is equal to 0. And that will be minus PA 0 power 0 is 1. So I will write it 1. That will be equal to moment at point B. So moment at point B will be equal to minus P times A. And that is the answer of our this question. Now this negative sign shows that moment at point B will be equal to P times A, and while representing this bending moment on beam or bending moment diagram, this will be counterclockwise movement, CCW, counterclockwise movement. And you can also see that movement at point B is again MA, which is counterclockwise here. So this is the answer of our second part. And that was all about this problem 5.104. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.